Hello guys, welcome back to the Tales of the Chemist of the Rings. Please hit the like and subscribe button, as it would mean nothing to us if you did that. Oh no! Ryan has been captured during his perilous journey to ORGO class. The Dungeon Master Jake has captured him and thrown him into prison made out of carbon.
Oh no!
Ryan is very scared. He has no idea of how to escape. In the background, Jake is laughing menacingly.
Oh no! I'm trapped by 6 carbons. What shall I do?
However, Ryan is an aspiring chemistry major with a chemistry PhD along with a Nobel Peace Prize in chemistry.
This could be really bad if this is a benzene ring. Benzene rings are aromatic and difficult to break out of.
Ryan, however, quickly spotted something important.
Wait a minute, there aren't any double bonds. Even better, I see 12 hydrogen bonds forming all around me.
Ryan quickly thought heavily about what he learned in his ORGO 1 chemistry class.
That means that each carbon around me is forming 2 hydrogen bonds and is singly bonded to another carbon in the ring I am trapped in. That means that the ring is just a cyclohexane.
Ryan wiped a sigh of relief when he realized that it was not a benzene ring, which was much more difficult to break down. Ryan looked through his sack of chemical goods. However, because he was still nervous, when he pulled out all his items, he accidentally dropped his BR2 everywhere.
No! I radically halogenated it.
Then, all of a sudden, Ryan remembered how to break the cyclohexane.
I can use a strong base like KOH. This will deprotonate a beta hydrogen and eliminate bromine in an E2 reaction, forming a double bond. That gives me cyclohexene.
Ryan adds KOH and heats the reaction. The bromine atom leaves as a leaving group and a beta hydrogen is eliminated. Cyclohex 1-ene is formed. With the double bond in place, the structure was weakened, but Ryan wasn't finished yet. He needed to break the ring completely.
Ozonolysis will cleave this double bond. By breaking it apart, I'll get 2 smaller fragments, each with a reactive carbonyl group. Then I can break free.
Ryan uses O3 for the reaction. The double bond in cyclohex 1-ene is cleaved, forming 2 molecules, hexane-dio. The prism was broken apart, but Ryan needed to reform the ring to stabilize the structure before Dungeon Master Jake returned.
If I use NaBH4, I can reduce one of these aldehyde groups into an alcohol. That'll set me up to kick the alcohol out. I can also do this with lithium aluminum hydride.
Ryan adds NaBH4, converting the aldehyde groups to a primary alcohol, creating a structure with an alcohol on each end.
Next, I'll add H+. This will hydrate the alcohol, turning it into a good leaving group.
Ryan carefully adds hydronium. The alcohol is converted into a good leaving group, setting up the molecule for ring closure.
With the aldehyde on one side and a leaving group on the other, this structure is primed to form a ring. Let's close this back up.
Ryan allows the reactions to proceed. The OH2 leaves, forming a carbocation. The alcohol group attacks the carbocation from the leaving group, forming a new ring with 1 oxygen atom. Ryan successfully rebuilt the ring, but now the new structure had a weak point that he couldn't exploit for his final move.
One last step. A simple dehydration will stabilize the structure and complete my escape. Hooray!
Ryan reacts the ring with hydroxide and dehydrates the other hydroxide, leaving an ester. Using his chemistry mastery, Ryan has escaped the carbon prison, leaving a fully reformed but weakened ring behind.